Alright, part 2 of our video on the 4-5 notes and 2x2 matrices. As I wanted to show you, there are other notations for the determinant. By the way, I want to remind you the determinant is just a number. Remember that the determinant is just a number. If you see 2, 3, 4, 5, that's matrix A, and it says find determinant A, that's what they're looking for. You may also see a notation that looks like this, where it just looks like absolute value bars. It really is just asking for the determinant. That's all. Which we remember we can do that pretty easy, like 10 and 12, right? This product minus that product, and so 10 minus 12 is -2. Okay, so remember the determinant is a number. When does a matrix not have an inverse? When does a matrix not have an inverse? Well, you think about this. A matrix involves what? You do all that stuff where you switch these two items, you multiply these two items by -1, but they stay where they're at, and then you have the 1 over the determinant, the reciprocal of that determinant out in front. Here's where we have a problem. When does a matrix not have an inverse? You think about a fraction. When does a fraction not exist? If the denominator equals 0. So if the determinant of the matrix equals 0, then there is no inverse, because we can't divide by 0. Okay? So keep that in mind. We're going to ask questions, and if the determinant ends up being 0, there is no inverse. Okay, next, solving a matrix equation. I want to go through an example of this with you, and you'll do more in class. Okay? We have a matrix times x equals another matrix. So, we need to find the inverse. We know that we are going to left multiply on both sides. You'll see that I left some open space between the equal sign and my matrix. So, that's what I'm doing here. So, -1 times 2. Remember, the first thing I need to do is find my determinant. So that's -2. That's 27. And of course, we're subtracting them, right? -2 minus 27 is -29. So I've got my reciprocal, and then times a matrix, right? What do? We switch the elements on the main diagonal, right? -1 goes up here, 2 goes down there. We multiply the other ones by -1, but they stay where they're at. Okay? So I'm going to copy this down over here because I know that's what happens. I copy it down over here. Obviously, I didn't leave myself a lot of room here, so I'll have to squeeze things in to make sure they fit in here. Okay, so I've got my information copied over. Now, what is going to happen over here between these two? The inverse and the original matrix. Yes, of course, the important but yet very boring stuff. The identity matrix, right? It becomes 1, 0, 0, 1 times matrix X. And we know that the identity matrix times any other matrix leaves me with that matrix alone, right? That was the important yet really boring stuff. Over on the other side, the reason I have you leave the fraction out in front instead of cramming it inside and having all those nasty, ugly fractions all over 29 is because of this process right here. We have that fraction. I want to take row times column using just the integers. Now this is a 2 by 2 and this is a 2 by 1. It is definitely possible because the inside numbers match up and the outside numbers are 2 by 1. So I know that this will be a 2 by 1 matrix, 2 rows, 1 column, which has 2 different numbers in it. Alright, so -1 times +1. That gives me 1. Plus -3 times 39. -3 times 39 gives me -117. So when I add those together, I get -116. Alright, something's wrong. What did I do? Negative 3 times 39 is 1. Must have done something wrong here. Nope, I'm okay. Alright. Momentary lapse in judgment. Alright, so next row times this column, that's positive 9. Plus 2 times 39 is 78. So 9 plus 78, what do we got there? 87. Now, the last thing I want to do is now I want to multiply this fraction times everything on the inside there. So I have negative 1/16. See that? Negative 1/16 divided by negative 29 equals 4. 87 divided by 29, 3. So that's my matrix X, my solution to this system of equations that we had back here. I found the inverse, I left multiplied here and left multiplied here. This stuff disappeared to the identity matrix and eventually gone, whereas this over here was where my answers were. And that's the rest of the notes. We'll see you in class.